Warning: this video contains clips and excerpts of a humorous nature not normally found in math class. These are intended to fight the adolescent condition known as short attention span, found heavily in the modern teen, especially when in school. The only thing you should attempt at home is the math. The rest, you just laugh at.
Hi, welcome back to AT Math. Today's 7-5 polynomials. Why it's more relaxing than a drive in the countryside. Now, first, we are going to label expressions based on how many terms you have. For instance, if you have a monomial, mono, well, they're all going to be either Greek or Latin, but mono means one, so one term. An example, you have 2x, could be one term, even though 2 and x are two separate things, when they're times together it just means 2x, so that's one term. Or a singular 7, or a negative 3wq, because all that together equals one value. X is one value. 13u squared is one value. Now look at binomial. Binomial means two. Bi means two. So two terms or two monomials. Example that is separated by a plus or a minus. So you have this value here plus another value. Here you have this value plus this value. So you have two separate terms, which makes it a binomial. Trinomial. Tri again means three. So three separate values separated by a plus or a minus. Now all these are called polynomials. Poly meaning any. So poly means any amount of monomials, whether it's 1, 2, 3, or 50 monomials. And basically any expression that is more than three terms, three monomials, is generally called a polynomial. So a quick review. Polynomials. Monomial means one, binomial is two, trinomial is three, and poly is all. Or a Venn diagram. You have right here, you have a trinomial and you have a binomial separate, but inside those are all monomials, and every omial at all is a polynomial. Now, a degree is the largest exponent of an expression. For instance, if you have 4x cubed minus 3f squared plus 2d to the first, you just look for the largest exponent, which in this case is a 3, so 4x cubed. Now, why is you looking for the large exponent? Because in the value of a curved line, when x, f, and d would be relatively the same, it's this exponent here, the cube, that over time will shape the line and therefore have the biggest influence. Another one, 1234x, 34y squared, or negative 2b to the fifth. Now even though negative 2 is the smallest coefficient, the b to the fifth power will start to, over time, determine the look of the line. We talked about that there. However, if the exponential numbers are being multiplied, then you add up the exponents to make one large degree. For instance, if you have x cubed times y squared, then you actually take both of the exponents together, because what you're saying is x cubed and y squared combined, will have a degree of 5. So basically it has the influence of 5. Or this one here, d squared, h to the fourth, 0 to the third, r to the fifth. Add all those together and you'll have 14. So basically the degree is 14. Or this one, 2y cubed x. Now x by itself is x to the first, so 3 plus 1 makes 4. Remember that a variable by itself is still an exponent of 1. So we add 3 and 1 to make 4. You try. Find the degree for each expression. Go ahead. Let's see what you come up with. I guess they're listed. Oh well. This one was 5 because of the y to the fifth. This is 9 because 3 and 6 are touching times-wise, so they become 9. And this is a 3 because these two are touching. And remember, is f to the first. Now, let's take a short break.
Good girl. Good girl. Say. Good girl. Good girl. Good girl. Say. Good girl.
And we're back. Now we need to put the polynomials in order from largest to the smallest. So take a look here. I have 23rd x squared, 2x cubed, minus 23, plus 4x. Really, excuse me, the largest exponent is still the x cubed, so that goes first. And what I'll do is I'll take this here, I'll write this down below and scratch it out. And then I'll take the next biggest, which is going to be 23x squared, because x squared is a bigger exponent than no exponent, or just 1. So I'll put this here, and I'll scratch that out. Now it's better to have an exponent than no exponent, so I'll put a plus 4x right there, scratch that out, and put minus 23. Do you have to scratch them out? No, but honestly it's so much easier when you get rid of what you've already used. You'll see what's left, and very easy not to miss things then as well. So I would highly suggest on your homework that you write this out first, even though you don't want to, then put them in order and scratch out what you've taken out. Don't forget stuff like 23, it has the negative in front, things like that. You try, go ahead. Alright, hopefully you had what I have listed below here, which is the negative 5 g to the 5th has the biggest exponent, so that goes first, which is right here, and then this has the next highest exponent, which goes here, then this is the next highest exponent, and this is the next highest exponent, don't forget the negative 2g, and then the 45. Quick break, and back. Now, just as polynomials have their own names, so do different degrees. For instance, a degree of 0, so let's say x to the 0, is called a constant. And a constant because anything to the 0 power is 1, so you're really not going anywhere. There's nothing to be had. You're just at that point. A degree to the first power is called linear because if we just have x, it's going to be a straight line. It's going to be some sort of line. There's going to be a straight line, not much to it. Degree of 2, quadratic, because it's going to be a curve. Let me draw a little curvy line there. And a straight line. And constant means you're going nowhere. Cubic, it's the third power, is going to look like this. Quartic is going to go back to the parabola but thinner. Quintic, like the cubic but thinner as well. 6th degree, 7th degree, 8th degree, and so on. So some examples. If I have 2x, because x, just x by itself, is a linear degree. 3x cubed is a cubic degree. So all you have to do is check the number and just check what you have here. That's all. X squared plus 3x, well, x squared is the big degree to worry about, and that's quadratic. 8 by itself has no variable, so it's going to be a constant. 4x to the 5th, x to the 3rd, because they're touching, they are the 8th degree. Now we'll give the degree in the polynomial. 5x to the 4th plus 23x squared is a quartic binomial. Let me explain. Quartic because the highest exponent, the degree is 4. Binomial because there's 2 terms. And 15x to the 5th, x to the 6th, it is 11th degree because these two are touching, therefore we combine the 5 and 6 to make the 11th degree a monomial because it's just one term. One more. Huge one here. What's the biggest degree? Right here. So it's going to be quintic, and there are 4 separate terms. Remember, monomial, binomial, trinomial, anything beyond that just called a polynomial. There could be a term, but we're not going to worry about it this time. If you don't have one of the 3, you're just going to say polynomial. You try, go ahead. I guess it's listed below. Notice here that the biggest degree is to the 6th power. 1, 2, 3, trinomial. Try again, go ahead. For real this time. I hope you remember that this was a degree for each one, so the degree is going to be 2. So I'm going to say, well, quadratic binomial, because there's 2 of them. Try again. So 24, it is a constant, because there's no variable to be had, monomial. Actually, for using a mouse, this is actually very good handwriting. So hooray for me. Then I had to go mess up with a bad picture, but you get the idea. Break time.
Ask someone to put their hands together and then extend their two first fingers. Now gently circle around their fingers, asking them to imagine a loop of thread becoming tighter and tighter. Amazingly, their fingers will actually drift together. Balance a straw on a bottle and then use your magical abilities to make it rotate. The secret is simple. Before you start, rub the straw on your t-shirt or a cloth, and then static electricity will do the rest. Ask someone to put their hand on the table and then bend their second finger under their hand. Now tell them you're going to use your magical abilities to prevent them moving their third finger off of the table. They won't be able to move it. Ask someone to hold their hand against yours, and then, using the thumb and first finger of their other hand to stroke the two first fingers. It will appear as if their finger feels completely numb. Now stare at the centre of the spiral. Keep on staring at the centre of the spiral. Don't take your eyes off the centre of the spiral. Keep staring at the centre of the spiral. And now look at the back of your hand.
And back. Now remember when you have to put the expression in order of exponent. In other words, 2x plus 3 minus 2x squared, the biggest degree is negative 2x squared, so that goes first. So I'd put that here and scratch that out. Scratching out the negative as well. The next biggest term is 2x, so I'll put 2x here, scratch that out, and put 3 and scratch that out. So it goes in order of exponent, like so. And now it says, now we're going to see what coefficient of the biggest exponent is. So now I've figured out that yes, negative 2x squared is the leading exponent. So now the leading coefficient, not exponent, coefficient is negative 2. So in other words, we're saying, okay, I know that it's going to be x squared, thus quadratic. But now, because negative 2 is not going to be up, you're going to discover later it's going to go down. And that's how you know that. Again, 7x squared plus 3x minus 2x to the 5th plus 2 minus 12x to the 4th. I'll save you all the time and just put it in order for you, from biggest to smallest. So this is leading exponent, and negative 2 is in front, thus the leading coefficient. So the leading coefficient, like that, is negative 2. You try. Find the leading, once again, coefficient. Go ahead. Hopefully you identify the 3x to the 9th as the leading, the biggest exponent, which goes first, and the coefficient is 3. Therefore 3 would be the leading coefficient. Break. And back. Now you will have many word problems that deal with following objects. Open your books to page 478 and read example 5. Let's make it a little larger. Example 5. Here we go, finally. A firework is launched from a platform 6 feet above the ground at a speed of 200 feet per second. The firework has a 5-second fuse. The height of the firework in feet is given by the polynomial negative 16t squared plus 200t plus 6, where t is in the time in seconds. How high will the firework be when it explodes? Here's why you need to know this. A firework obviously has to be shot off the ground in a certain height for everyone around to see it. However, you have to make sure that it's high enough not to hurt the public as it's, coming down, and that it's not so high up that people can't see it based on how high. So you want to have it high enough that people can see it from a long ways away, not too high that it's a mile up in the air and this little poof about yay big. So you have to find that middle ground. Besides, the farther away you are from the people, the smaller the boom will sound as it goes off. So you have to find the right number. And that, of course, is a mixture of how much gunpowder and blah, 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 but I don't want to get into all that. The point we have to learn is negative 16t squared, which is always going to represent gravity. So anytime you see negative 16t squared, you think gravity. The 200t is the lifting force. That's how much thrust it has. So if it was a smaller thrust, if it was smaller gunpowder, it might be 100t. If it was a lot more, it might be 1000t. It doesn't really represent how fast it comes off the launch pad, but how long it'll be going up before it runs out of fuel and gravity makes it come back down. And the +6 means there's probably a launcher of 6 feet, or in this case, let's say it's a platform of 6 feet. So okay. Which makes sense because a lot of fireworks are set up and then they're run by remote control. They're not always a guy who sits there with a little lighter. You know, we're talking about big league fireworks here and professionals. Of course, don't go trying to light off a bunch of fireworks at home and blow your hand off. You know, go see them at the professionals, because everybody knows that fireworks are illegal in Illinois. Therefore, we only go see them at public events where they're authorized. Anyway, so -16 t squared plus 200t plus 6. Now what they want to know is a 5-second fuse. We'll just drop 5 in for the t here and 5 in for the t here. So you have 5 seconds of Earth's gravity pulling down the rocket, which is -16 5 squared. As time goes on, that number goes up, the gravity starts to win. So no matter how high you think you're going, gravity eventually will have its way and pull you back down. The other one is 5 seconds of thrust at 200 feet per second. So let's take a look. 5 squared is 25. 25 times -16 is -400. So in 5 seconds, the Earth will have pulled that rocket down 400 feet versus the thrust of 200 times 5, which is 1,000. So the rocket's gone up 1,000, but gravity has pulled it down 400. So it's actually only going up 600 in 5 seconds, plus the 6 on the launch pad. Therefore, it's 606 feet total. So we'll take a look here, and I'll explain this. Gravity, -16 t squared. Rising force, which is how many feet per second it's going up, is 200x. Starting height of the object, we're talking about the platform, which is 6 foot. So that's what you have for all those. And say it's a 5-second fuse. I told you I'll drop the 5 in here and here, as we discussed. So remember, 5 squared goes first, not 16 times 5. No, 5 times 5, because the square goes first. Make that as -400, so the Earth's gravity pull over 5 seconds will be -400 feet, but the rocket's thrust will put it at 1,000. Now you might say, wait a minute, the rocket will never come down then. Well, not exactly, because the x square, as the seconds go on, this number gets exponentially bigger than this one. Within 10, 20, 30 seconds, I guarantee you that rocket's coming down for that reason, so that goes coming down. Anyway, in 5 seconds, it'll be 606 feet above the ground upon exploding, which is probably going to be 2 football fields up, which means probably people will be able to see it for a couple miles away easily. It'll be a nice big boom. They'll have a nice volume across the area, so it's going to be a successful firework. You try. You throw a baseball in the air with a force of 50 feet per second. The ball leaves your hand at 5 foot from the ground. So I'm saying when you throw the ball, it's about 5 foot above ground. How high will it be in 3 seconds? So here, hint. -16 t squared, that's the Earth's gravity. That will not change unless you leave Earth. Here's Earth's gravity. 50 t is your throwing force of 50 feet per second and 5 foot from the ground. So just drop the 3 in. Go ahead and try it this time. Let's see how you did. So we'll go ahead and give it a try here. -16 t squared plus 50t plus 5. We drop the 3 in for all these. 3 squared makes 9. 50 times 3 is 150. So 144 plus 150 plus 5. It's only 11 feet off the ground. And you might say, well, how is that possible? I can throw a ball and it's going to go higher than 11 foot, especially after 3 seconds. Well, yeah. But the idea is when you threw it up, it's already on the way down. So you might want to start getting ready to catch that ball, because 11 feet, you have about another third of a second to get that glove up and catch it before that ball comes down and whacks you one. So why so low? Because it's on the way down. If you're curious, if you try plugging 4 in, notice what happens if you plug in for 4 seconds. With this gravity and this throw, notice that you get -51, meaning that you would be 51 feet in the ground if the ball were to continue to travel and not hit the ground. So you could be like on a cliff and throw, and second 4, it would be 51 feet lower than where you started. And that's that. We're going to do more of these story problems. Don't worry. Thanks again. I'll talk to you later. Bye.
Она болеет, она специально.
Он сейчас сам испугается ее. Она кричит! Она такая. Вот она девушка, когда увидела, сколько их там. Фига она волнуется. Вика, ты переживаешь. Мамку кусать. Нифига себе. Она ошибается.
Она сейчас вас разгонит, как кошка размером. Вот в ужасе, где вообще стая, блин? Где отсюда?
Саша, подождем.
Да не подождем, а под дерево.